Hi everyone, we are in chapter 4.1 related rates problems. Let me give the following introduction. In some problems, the given x and y parameters may be depending on a third parameter, let's say t. And in such cases, we say these two variables are related by an equation. So we have a main equation, and in this main equation you may have x terms and y terms, but in our case this x will be a function of t, y will be a function of t. You may have more variables, of course, but this is just an example. So thus, by implicit differentiation, so when you take derivative of x and y, you have to take it with respect to t. Then we have a relation between x and y, and this relation gives us, since we have rate of change problem, this is differential, this is a derivative question in fact. So you will evaluate the problems, for instance, the change in x or the change in y when the time passes. Okay. In other words, we say the rates are related to each other, and we can compute one of these rates of change if we know the other. So let me first remind you that this lecture will be in two parts. In the first part, I will give the main facts and maybe some simple examples. Then in the second part, we will have just examples. So strategy. So we have some process for solving the related rates problems. This is not an obligation for you, but if you apply these steps, it may be helpful for you. For instance, the first one. First of all, from the very beginning, of course, you must read the question carefully to understand the question. What is asked, what are given, what is input data, and how you can get an equation from this data. If possible, draw a sketch of the problem. This is not possible for all of the problems, but it may be useful if you can. And for some of the problems, it is really necessary to sketch it. And assign variables to which are input variables and which variables are given, write them as a function. So determine the independent variable on which the other quantities depend and assign it a symbol such as t. For instance, you assign, if the volume is asked, you have v of t. If the area is asked, we have a of t, and so on. Okay, we can have x of t, y of t, so on. So all of these parameters are a function of t. They all depend on t. And find an equation. For instance, if the question is about a volume of a sphere, for instance. So if you are asking a sphere question, so then volume of this sphere will be 4 over 3 pi times r power 3, but r is depending on t again. Okay, and the main equation is important, in fact. So to write this equation is important. Why? Because when you take derivative, you will write the derivative of this main equation with respect to t. And here also I forgot to state something. So this v is a function of t, in fact, v of t. And differentiate both sides of the equation, stage 4, with respect to t, and determine how the rates are related to each other. So here it is important to take derivative correctly, because everything is depending on t. So it means when you take derivative of 2x, derivative of x squared, for instance, it makes sense. The derivative of x squared will be 2x times x prime, because you have 2x t times x prime t. X is a function of t. That's why pay attention. We will go through in examples for this type of details. Okay, in the stage 5, substitute the given information into the related rates equation and solve the unknown rate. Okay, these are the main steps that you can follow or not, but in any case, it may be helpful for you. So let us see the question, the following. Let me make it a little bit smaller. Okay, the top of a ladder 5 meter long rests against a vertical wall. Okay, here we have a wall here, as you see, and we have a ladder. If the base of the ladder is being pulled away from the base, so here the base, this is the base of it, and it is pulled away from the base of the wall at a rate of 1 over 3 meter over second. how fast is the top of the ladder slipping down? So the question asks the base, the top of ladder, top is here, so it will be, if you put it away from here, it will be falling down in this direction. So I sketch it here indeed. Okay, when it is 3 meters above the base of the wall. Okay, our first sketch is the T0 case, and this is at T, maybe we can say T is equal to 0. Here T is equal to T0 at some time T0 which is greater than 0. Okay, when we have 3 meters above the base of the wall, okay, we have here y means y is given as 3, but at the beginning 5 meters was given. This was given. 5 is the ladder distance from here to here. So as you see, we have the distance of ladder is the 5 meters. So then if this is 3, this is 5, this is the right triangle, so you can find xt0. In other words, the given data are yt0 equal to 3, xt0 equal to 4, and moreover, what is given? Something given here. Okay, what's that? 1/3 meter over second. So it is in x direction, so it means we have x prime t is also given. Okay, this is my x prime t0. And what is asked? Y prime t0, because it says find this rate, slipping down rate. Okay, we need an equation, a main equation. So when you look at this question, what can you think about the main equation? The main equation is of course from the geometry of the given shape. So the figure here, if you call it xt, here if you call it yt, you see that x squared plus y squared is equal to 25, and this is our main equation. Our main equation is important in order to use derivative. And from the second figure we have yt0 equal to 3, x prime t0 equal to 1/3, and xt0 equal to 4. This is also given. So now apply derivative to the main equation here. Okay. Let us use differentiation. So I wrote everything in detail in order to make everything clear for this example. So differentiate the main equation in order to find y prime t0. If you take derivative, as I said, derivative of x squared is not equal to just 2x. It is equal to 2x times dx over dt. Derivative of y squared is 2y dy over dt. Or it is better to use maybe this notation, 2x times x prime, 2y times y prime equal to 0. And substitute the given data into this equation at time t0. It means at t0, xt0 equal to 4, x prime t0 is 1/3, yt0 equal to 3, y prime t0. This is asked. And when you write everything in the equation, you will of course get y prime t0 is equal to -4/9. Okay, now we have to write a conclusion. This is -4/9 because it is falling down. It is in the negative direction. Okay, this is the ladder is falling down at a rate of 4/9. Okay. A second example. In this example, we have another geometrical shape, which is sphere. We have a spherical snowball with an outer layer of ice melts. So whenever it melts, it means it is decreasing. It's getting smaller, in fact, so that the volume of the snowball decreases at a rate of 2 centimeters square over minute. Okay, the volume in this case, v prime is given. Whenever a rate is given, this rate is derivative indeed. Okay, pay attention. The rate is related to the derivative, so it means you must write it either of if a side is decreasing, you say x prime is equal to 0 or y prime equal to 0, or equal to the given number. But in that case, the volume of the snowball is decreasing, so it means v prime is given. So this is my v prime, but it is decreases means it must be -2. How fast is the radius? Again, whenever the question, if it is how fast, it means it asks again a derivative. Okay, how fast means it is asking the derivative, the related rate of the given radius whenever the diameter of the snowball is 10. Okay, so let's go to the solution. Another trick here is the following: 10 is given as a diameter, so a diameter means 2r. Okay, it is equal to 2r, the whole distance from one side to other side, the biggest distance. So then r will be 5. Okay, so this spherical snowball is decreasing so that it is getting smaller here as in this shape, and it is melting, so diameter will be r is equal to 5. What are given as dv over dt equal to minus 2. This is also given, and it is decreasing. That's why it is not given minus 2 in the question, it is given 2. But you have to understand, when you see the decreasing term here, you must write minus at the beginning of the given quantity. And what is our main equation? Our main equation here is the volume of the sphere, which is 4 over 3 p r power 3. Don't forget, r is a function of t. Then derive the main equation with respect to t. We have dv over dt equal to 4 over 3 p times 3r squared times r prime of t. You must be able to write this derivation because you have studied already the implicit differentiation. Okay, so if you put now the given data, minus 2 equal to 4 over 3 times pi times 3 times 5 squared, because r is 5, r prime. So r prime of t0 will be equal to minus 1 over 50 pi, which means radius is decreasing because of negative sign at a rate of 1 over 50 pi centimeter square over minute. As a third example, we can consider a cube, another geometrical figure. The volume of a cube is increasing at a rate, at a constant rate, 27 centimeter power 3 over second. What is the rate of change of surface area? Okay, two different things are given. The volume is increasing. So what is surface area? And the rate of change, since it is asked, indeed you have to evaluate a prime. Okay, a prime of t0. First of all, you must know what is the surface area. Surface area of a cube means you have 6 squares here, and you evaluate all of the areas of these 6 squares. So if one of the area is x squared, then all of these areas will be 6 times x squared of t. Don't forget to write x as a function of t. Moreover, what is given? Volume is given. Volume is increasing means v prime of t is equal to 27, because it is given as an increasing rate. So if it is 27, I can evaluate from the very beginning of the volume of a cube is x power 3t. So if we take derivative v prime, you have 3 times x squared times x prime t. And this is equal to 27 means what? So if you write 27 equal to 3 times 3 squared times x prime t0, you get x prime t0 is equal to 1. This is important. In fact, this is what we need from the given data. Then go back to a t equal to 6 x squared. We need a prime, so evaluating a prime t will be 12 xt times x prime t. So then you have xt was equal to what? Xt was equal to 3, x prime t was equal to 1. So then I have 12 times 3 times 1, which is 36. So conclusion, surface area is increasing at a rate of 36 centimeters square over second when the side length is 3. Okay, maybe one more example for that part. This is also a geometrical figure question. If you sketch it, it may be better to understand the question. In that question, it says a water tank is in the shape of an inverted right circular cone with base radius 12 meter and height is 16 meter. Okay, this is our base of cone, and age is given, r is given, age is 16. So I wrote everything which are given in the question on the left side, and I will try to evaluate my calculation on the right side. So on the left side, again, what do we have? What is the volume of the cone? We have 1 over 3 p r square h. Everything, r and h and v are depending on t. So let me read the question again. If water is flowing into the tank at a rate of 10 meter cube per minute, find the rate at which the water level is increasing when the water is 4 meter deep. Okay, when h, so this means when this is equal to 4 and v prime equal to 10, what is asked? It is asked to find the rate of which water level is increasing. So find the rate of water level means we have to find h prime of t0. Okay, this is asked. If you understand what is asked in the question, now everything will be easier. Now we have v prime is given, ht0 is given, and what I have moreover, I have the volume is equal to 1 over 3, so maybe I can write somewhere here, volume is equal to volume of t 1 over 3. Okay, I have written, sorry, this is already here, it is already given. Okay, we have, it is given here, volume is given here, but when I take derivative of v with respect to t, I have two parameters, r and h. So you have to take derivative of first one times second one times first one, a multiplication. But there's something more, there's something more given in the question that you must use it. What is it? We have r is 12, h is 16, so it means there is a relation between r and h, and which is given here. R over h is equal to 12 over 16, which can be written as r is equal to 3h over 4. So now go back to my main equation. This is our main equation, u of t, and write, instead of r, write 3h over 4 here. If you do that, your question will be depending on just one parameter and one variable. We have just h, we have no r. So then we have 3 times, so we have 9, cancel each other, we have 3, so something must be cancelled here. Let me see. 9 over 3, we have 3. I have a mistake, I think. R squared times h. Do we have something more here? Because we have to have square of 3 is 9. 9 over 3, we have 3. 3 over here we have 16, not 4. Okay, this is a mistake that I haven't remarked previously. Times h power 3. Okay, not 4 here. This is also false. We have 3h over 16 pi. Okay, if you now derive this expression, okay, we have 3 over 16 here, 3 over 16 times, again we have 3 is coming from h, 3h square times h prime times pi, and then put the values in the given quantity. Put h is 4, we have 16 and 16 cancel each other, so here we have again 16, we have 9 here. Okay, maybe better to erase and write it again. 16, and here we have 16, here we have 9, so this 16 cancel each other. H prime t will be 10 over, okay, here the answer is also not true. We have 10 over 9 pi. Here again 10 over 9. Okay, if I have any mistake, you can write, and you can just tell me by email if you find any mistake in the calculation. Okay, this is the answer. H is increasing because the answer is positive sign, so it is increasing at that rate. So let us stop at that point. We may continue in the second part for the other examples.